All right, so I'm going to use that graphing calculator when I have to. If I don't have to, then I'm going to find, like in this case, I'm looking at local maximum, local minimum. If I knew how to find that on my own, I totally would. I think I might need the graphing calculator for that though. So let's look here. Local maximum. So this one right here, the 0.06 is my maximum, like it's higher than the stuff on the left and right. And then this point down here, 2, that's my local minimum. It's lower than the stuff on its left and right. So there's my local max and local min, 0.6 and 2. All right, now based off of the local maximum and local minimum, I can get the increasing and decreasing inequalities. So off of, let's see, if I'm going left to right, left to right, it's increasing, going up, 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 up until it gets to that max. And my increasing, decreasing has to do with, do you guys remember X's or Y's? If I want an increasing interval. Here's my hint, I'm going left to right. Does that have to do with X's or Y's? Yeah, X's go left and right. My Y's go up and down. I am looking that it is increasing, it is going up, but from what X value to what X value. So those are going to be from, it looks like it goes to the left as far as it can, so to negative infinity up to the X value 0.
Oh, yeah.
Does this sound familiar?
I always think it's from the 0.
So go put this in here. So negative infinity up to 0. So again, that's not an XY point. This is an interval. Oh, it would not include it. No, but so they said to write it as an inequality. I wrote it as an interval. So I can write the same thing as an inequality. I could say, again, left and right has to do with X's. I could say this is all the X's that are less than 0. Everything to the left of 0, essentially. That was my like increasing section. Now, is that the only increasing section? Let's look at that. If I'm going left to right, increasing until this 0.06. Okay, and then it starts decreasing. Will it ever be increasing again?
Yes.
Yeah, from where?
Oh, okay.
Oh, the 2 point. Okay, so from that minimum. Everything after that, I mean like left to right, everything after that is going to be increasing. So again, if I'm going X values, I'm gonna go from the X value 2 to infinity. I think online they do want you to do inequalities. I could put 2 to infinity, or I could do an inequality like this. So I could say all the X's are less than 0, and all the X's that are greater than, like everything to the right of 2, right? So there's my inequalities. And then decreasing inequality, I think it was between those guys. It was going down, decreasing between those guys. Which means I've got to have my X. I want the X's that were not less than 0, but all the X's that are greater than 0, and then the X's that are less than 2. It's like between the 0 and the 2. So if I'm doing this as an inequality, this is how I state my inequality. Again, mouth eats a bigger number, right? So this one, if I'm just looking at 0 less than X, I would say this X value of 0, the 0.6 here, that is less than, that's to the left of this decreasing section. And then the X is less than, like this whole decreasing section is less than the X value of 2. So that's how I set up this inequality. All right, and then we're going to graph this. We're going to try to plot these points. I think the max and min I could plot fine. That was 0.6. All right, I can plot that point. 2, 2. All right. It was the x-intercept that wasn't so pretty. Negative 1.19, blah, blah. It's a little over like -1, right? Between the -1 and -2, but pretty close to the -1. All right. And then I'm going to connect these. let's keep in mind that when it hit the 0, 6, that was a maximum. So it's gonna like bounce back down. And then when it hits the 2, 2, that's my minimum, it's gonna bounce back up. All right, so I'm going through this point. Ooh. Ooh, my goodness gracious. Okay, let's do it like this. Okay, max turns around, hits the minimum, turns around, and is increasing after that. All right, so there's my graph. Any questions? You guys online, I know it's probably tough to see this. Let me know if you guys have any questions. So you guys in the classroom, you guys can do this on your own? You guys at home? How are we doing? Good, good. It might ask you for increasing and decreasing inequalities, yeah. So these again are inequalities, not intervals. Make sure the mouth is eating a bigger number, right? All right, thanks you guys at home. Looks good, looks good. Okay, I'm going to then move on to the next one. Same deal. If you know how to factor it, great, do that. You can get like an exact value. If you're not sure how to, or if we can't find anything, we can go into Desmos here. Like I said, you're not usually able to do this, but in this particular lesson, yeah, we can do that. So can somebody read it to me? What's the... Wait. Okay. Come on. All right, x to the fourth minus 6x to the third, okay. Plus 3x squared. Plus 10x. Minus 3. All right, got that whole messy thing in there. So here's our graph. All right, so were you guys going to come up with this x-intercept of negative 1.137? Probably not, especially because that's like rounded. It has an even longer decimal than that. So I'm going to click on these. I'm going to identify all of my 4 different x-intercepts. All right, and so we are, let's write these down here, negative 1 point, maybe I'll put that like this. Yeah, we do need all 4 of them. Yep, we need all 4 of them. All right, so is that a positive 0.2890? Now pay attention to what on big ideas, what they want you to round to. So Desmos itself has rounded to 3 decimals on each of these, right? Okay, so pay attention if they want you to round to the nearest 10th, 100th, 1000th, whatever. Pay attention to those kind of instructions. And then my last one here was 5.0330. Okay, so I got all 4 of my x-intercepts. Goodness gracious. Okay. It also needs maximums and minimums, local max, local min. So click off that there. My local max, let's see here, goes down. Okay, I think this one's a minimum. This one's low. Goes up, up, up. It looks like a what? Another one, another minimum down here. That's true. There's another minimum down there. If I'm just looking for the local max though, I think there's this one right here. And then as I go up higher and higher and higher, am I gonna find another maximum? No, it's going to go up to infinity. It's not going to turn back around. You can't see any of the lines coming down, right? So this is my only maximum, as messy as it is. So 1.108, and again, pay attention to what the, what the big ideas tells you to round to. All right, messy, right? Were you guys really going to calculate this on your own? Probably not, but we're learning how to find it. My local minimum. Okay, so I see a local minimum down here. That is a negative 0.57 for my x and a negative 6.509 for my y. Okay. So am I good? I got my max, I got my min. Yeah, we're good. I'm missing something. Did anybody notice? I think you were telling me before.
Yeah, there's another like.
There's another minimum?
Yeah, like there's that one point that goes like.
Yeah, like way down here. And I know it's down there because I could see it bounced back up. So it must have turned around at some point down there. So here is that point that we were going for. This one is the point, let's see, 3.962 and then a negative 43.038. Okay. So now that's all of my minimums. I had 2 of them. I know, so yeah, you had to go down to negative 43. It's pretty far down there. All right, now that I have those, I actually can use those. I don't have to look at the graph anymore. I can use the maxes and mins to help me with my increasing and decreasing inequalities. So let's see, this one was down at negative 43, blah, blah, blah. I'm gonna kind of just put that down here. We'll pretend like that's negative 43. All right, so I'm gonna hit some of these points. I'm gonna hit the x-intercept negative 1.13, a little further than negative 1. I've got my 0.2, so it's a positive number, not much bigger than 0 though. I've got 1.816, so it's kind of close, a little less than the 2. And then 5.033, it's almost exactly 5. Okay, so those are my x-intercepts. You okay with these x-intercepts? Yeah. My, let's see then, my maximum was at 1.1, blah, 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 a little over 1, I guess, and then up to a 5.1 y value. So a little over 5 for my y value. Pretty close up there. There's my max. Minimum, I had 2 minimums. We were at a negative 0.57, like almost negative 1/2 kind of, and then to a negative 6.509, so like a negative 6.5. I'm estimating like a negative 6.5, but if I enter the decimal, I'm not going to put negative 6.5. I'm going to put negative 6.509, whatever they told me to round to. I rounded to 3 decimals on each of these, but pay attention to what they want you to round to. And then my other minimum was way down here at this negative 43.038. It was almost an x value of 4 down to this y value of negative 43. All right, here we go. I did know that as far as end behavior goes, weren't both ends like going up? Yep, okay. So keeping that in mind, this is where I have to take this thing off. All right, so let's see if we can hit these points here. I'm gonna hit that one down to my minimum and whoop, bounce back up. It goes through the x-intercept up to the maximum and oh, turns around. Goes through the x-intercept again, down all the way down to the super low minimum and then whoop, bounce back up. Through the x-intercept again and off to infinity. So I hit all the x-intercepts, bounce back and forth between the maxes and mins. All right, so that with the graph, I can use that to kind of get my increasing and decreasing inequalities. All right, so as I go left to right, I'm going down at the beginning, right? Decreasing until I'm going to chop it off until right there. So I am decreasing from, it looks like negative infinity up to, let's see, this x value was one of my minimum x values. It was x value of negative 0.57. Okay, so this is where I usually see people do stuff wrong. They look at their graph and they estimate off of the graph as opposed to finding, like using the numbers that we already wrote. Like it looks like on my graph, I mean, I estimated I got as close as I could to that little decimal, but if I look at what I circled here, I can tell that was a negative 0.57. Was I really going to get that close off of estimating what this graph looks like? Probably not. So I'm going from an x value to an x value. So notice I did not use the y value. I just took the x value. I went from negative infinity until the negative 0.57. And this is an interval from where to where. If you need to make yourself a note about that, go for it. From one x value to another x value. It was decreasing in that section. So it was decreasing at the beginning here and then, oh, turns around, now it's increasing. So I'm going to pick it up where I left off at the negative 0.57. From there, it is increasing, increasing, increasing until this x value, which was, let's see, that was a maximum, right? So the maximum, the x value in that maximum was 1.108. So again, I'm looking at x values, because I go left to right, and left and right are x's. All right. So yeah, let's pick it up from there. If I keep going after that, I'm like, ooh, now I'm decreasing until, oh, until there you go. Do I want to stop at the negative 43 then? What would be wrong if I went up to the negative 43?
Oh,
Just the x values. Is that what you're saying? Yeah, I do need the decimal, that's for sure. But I need the decimal of my x value. This negative 43, whatever, that's a y value. I need to go from x value to this x value. All right, I'm looking at x values. The x value where it started was the 1.108. Up to this x value. So the x value at this really low point, here's the x value, that really low point, 3.962. Again, I'm not estimating it off my graph. I'm looking at the graph to figure out where it is, but I'm taking the numbers out of the x's in my maxes and mins. All right, so then, if again, I'm going left to right. So from there on, I am, whoop, increasing up to infinity, yeah. So from that x value again, what was that x value? It's a really low point right here. Yeah, 3.962 up to infinity. Okay, it's increasing in that section. All right, looking at it, you good? All right, so these are, again, intervals. From what x value to what x value? Okay, so make yourself a little note here if you need to. These are all x's. From where to where? From what x value to which x value? The y's, I put an xy point for my local max and min, but I'm not really using the y's from those xy points on my increasing and decreasing inequalities. Now, online, I think your maximum and minimum, I think they just straight up want the y value. If I remember correctly, I don't think they want the xy point. I think we talked about this yesterday as well. Let's look at this. So yeah, your local max and local min, they wanted like a straight up y for it. So I found those xy points. Like I found these xy points, but they're probably online, they're going to want the straight up y value. So this would be a 5.109. They want the straight up y value. I would just do y value, y value. You know what I'm saying? There we go.
They're trying to eat.
Yeah. So when deciding which point is the local minimum, do I just choose the shortest graphing point? Okay, so I'm gonna have to, the local minimum, I didn't quite understand what you're saying about the shortest point, but what I did want was some point that was lower than the stuff on the left and the right. So like this is a local minimum right here because the stuff to the left is above it, the stuff to the right is above it, so that would be a minimum. It's below the stuff on its left and right. Oh. Does that help clarify at all? I wanted both of my minimums, yes. There were, so this one was lower than the stuff to its left and right. This other point over here, that is lower than the stuff on its left and right, so they are both considered local minimums. Nice, okay. And then just a reminder, when you do local minimums, I think that, not Desmos, I think the big ideas wants just the Y values of those minimums. I had to kind of figure out when I was putting it on the graph, I had to get my X and my Y so I could actually put the point on my graph. But once you type it in, they want you to just type in the Y values. Okay. All right, any other questions? You guys online, how we doing?
Miss Jane?
Yeah.
So I started working on the assignment, but there was one problem where it was like where I had to find the local maximum and the minimum. And like there was one problem where it was the square root and then like 1.3, but like it wasn't working because there's supposed to be a line above 3. So like how do you do that on the computer? Sorry.
I caught some of that. I'm not looking at the problem myself, so I don't think I quite understand what we're talking about. You had to graph it? Is that what you had to do? And you had to round it or something?
So you know how yesterday we had to find the x-intercept and then we had to find the maximum and the minimum.
Yeah. Yeah.
So when I tried to put the answer in, it was like the answer was a square root with 1.3, but the 3 had a line above it.
Like this?
Yeah.
Okay.
So like, but it just wasn't working whatsoever. And like I was so confused.
So if they want you to find the square root of the 1.3 repeating, okay, so here's my 1.3 repeating. And if I take the square roots of that 1.3 repeating, I would then round this. Did they have you round to, what decimal did they have you round to?
I think I rounded to the 100th.
There's 100th, so second decimal place?
Yeah.
So I would, okay, so I wouldn't put it in as this like 1.3 under a square root. I don't think I would do that. I would put the number 1.15 as my final answer.
Okay, thank you for telling me that.
Yeah.
I also have another question. So if I was gonna do that what you just showed me, would I also write that on like tests and stuff?
Yeah, so if you have this big old decimal under a square root, if you're doing stuff in decimal, just get the final decimal. If I have something like, so if I'm doing the square root of 4/3,
Portia, don't go upstairs.
You can do whatever you want.
No, she has a broken back.
Oh, never mind.
all right, are we good? Okay. That's okay. All right, hopefully I answered that question. All right, I'm gonna move on to this one right here. So for this one, we're talking about an even function and an odd function. So your even functions, when you sub in a negative x, it actually doesn't change anything. It's the same thing as your original f of x. My odd function, when I sub in a negative x, it's like the original one with a negative out in front of it. So I'll give you an example of each. I think they're going to call it even and odd function because it kind of has to do with even or odd degree. So like this one down here, if I do f of negative x instead of f of x, like instead of x cubed, I've got a negative x that's cubed minus 7 times negative x. I replaced both of those x's with a negative x. And I want to know, does that get me back to the original one? Like when I simplify down, does it get me back to the original one? Or is it going to be like the original thing was multiplied by a negative? Or neither, maybe neither. So if I simplify this, keep in mind here, any odd exponents, look, I've got 3 of these. 3 is an odd number, right? But it's not divisible by 2. An odd number is not divisible by 2. That's the whole point, right? So the reason I care about that even versus odd is because 2 of the negatives together makes a positive. Negative times negative is positive. But then I've got like this leftover negative. I've got 3 of the negatives. So I end up with an overall negative in front of my x cubed. Like this would be a positive x squared times this other negative x. That gives me this negative x cubed. Okay, so any questions on my whole negative x to the third?
This is the even function.
I had to decide even, odd, or neither. Is that what you're talking about? And the way I decide about the even or odd or neither, one of the ways that I could do it is by subbing in a negative x. I want to see if it gets me back to the original function, or it's going to be like a negative in front of my function, or neither. So I simplified this first guy. The next one, I've got a negative 7 times negative x. So negative times negative is positive again. I've got a positive 7x. Okay, so if I compare that to this original, it doesn't look exactly the same as the original, but is it the original with a negative in front of your function? Is it like this whole thing times negative 1? You're saying yes. If it is, how come this one's a positive? Yes. Okay. So I see people mix up on this a lot. What I see people do is they think it's just going to like tack a negative right there or something, but that's not the case. It's got to, if you're going to have this whole, I'll do this in another color. If I'm going to have a negative on my f of x, it's going to be this entire f of x all multiplied by a negative. That whole thing. So like I would have to distribute the negative to both, and I would get a negative x cubed and then a positive 7x, which, yeah, those match. So for that reason, it's got a negative in front. This is an odd function. Because those are equal to each other, we're going with an odd function.
We just figure out the function.
Yeah, so determine whether each function is even, odd, or neither. Those are your only 3 options. Either even or odd or neither. So let's try this again. I'm going to sub in a negative x. It's a g function, so I have g of negative x, but same deal. I'm putting in a negative x. All right. Now my negative x cubed, remember I care about like 2 of the negatives together gave me a positive x squared, but then I had this leftover. If I have it a negative x to the 4th, right? Oops. To the 4th means I've got like 4 of these negative x's multiplied together. Does it end up with a positive or negative? All I really care about is positive or negative. Wait, which one? Positive. Okay, these 2 multiplied together gives me a positive. 2 more negatives again multiplied together gives me a positive. I've overall got positive times positive, which is positive. So this ends up with a positive x to the 4th. All right, what about my x squared? This turns into a positive x squared as well, because I had 2 of the negatives multiplied together gave me a positive, so positive x squared. What about the -1? Do I change the sign on the -1? Ooh, there were no negatives in there. It wasn't like a negative times negative or anything. Okay, so is this the original f of x?
Yes.
It is? It's the original f of x? Oh, okay. Which means that this is then an even function. It got my original function. Even. I'm sure you can probably guess what the next one does, but we're going to practice that just in case. I'm going to put a negative x in again. Negative x to any odd exponent. This one's cubed again, where really any odd exponent means it's going to be like a negative in front of it. I've got negative x cubed. If I had like negative, let's see, if I had negative x to the like 9th, 9 is an odd number, right? So that would be like a negative in front of my x to the 9th without the parentheses anymore. So this happens with all of my odd exponents. This negative x cubed turned into a negative x cubed, but one where the entire negative x was being cubed versus now just the x is cubed and tack on a negative. Plus 2 here, that does not change. Now, is this the original f of x function? Does this match the same thing?
No.
The x cubed versus negative x cubed, they're not the same. Okay, what about, it is an x cubed and a negative x cubed. Does that mean that they multiplied the whole thing by a negative? Did they change the signs on everything? No, they changed the sign on the x cubed. That got a negative, but they didn't make a -2. It's still a positive 2. So for that reason, we are neither. Oops. All right. And I think that was all we had. Just, I do want to look at this real quick graphically. Your even and odd functions, what it looks like on a graph. Your even function is symmetric about the y-axis. Like if I fold it in half, like if I put like, if I fold it in half, they're the same on both sides. And this one is symmetric about the line y equals x. So like that slanted line. If I rotate it, basically, if I rotate it 180 degrees, I get the same thing. So the green lines that I have here, these are what it's symmetric about. Symmetric about the origin. I guess it's not even a line, it's a point, it's an origin. Like I would rotate 180 degrees around that point. So like half a circle, right? If that goes half a circle, I get to that other point. If this goes a half a circle, go to the other point. 180 degrees around that point gives me the same graph. All right.